Assalamu alaikum and good morning. So in this video lecture, we'll be discussing inventory management. So we know that operation managers have a mixed attitude towards inventories. On one hand, of course, inventories are costly, expensive, because you are tying up considerable amounts of working capital. Second, they are also risky because items held in stock as inventory could deteriorate, become obsolete, or just get lost. And of course, they take up valuable space in the operation that needs insurance, security, and rent, and other operating expenses. On the other hand, inventories provide some security in an uncertain environment that one can deliver items in stock if customers would demand. So this is the dilemma of inventory management, that in spite of the cost and the other disadvantages associated with holding stocks, they do facilitate the smoothing of supply and demand. So we will learn here the inventory models. Okay, so what is our objective for inventory management? So our objective is to maintain a sufficient amount of inventory to ensure the smooth operation of the firm's production and marketing functions, and at the same time avoid tying up funds in excessive and slow-moving inventory. Okay, so in managing our inventory system, so often managers are involved in three major types of decision. First, how much to order. Because every time a replenishment order is placed, how big should it be? That should be the next question. Or sometimes called what is the volume decision. Second type of decision, when to order. Okay, so at what point in time or at what level of stock should the replenishment order be placed? So this is sometimes called the timing, no? The timing decision. And the third type of decision is how to control the system. Okay, so what procedures and routines should be installed to help make these decisions? Should different priorities be allocated to different stock items? And how should stock information be stored? So these are the types of decisions. So we always decide these three decisions because inventory carries substantial cost. Okay, so these are the major categories of inventory cost. First, we have the ordering cost, okay, or the setup cost. So these are all the paperwork needed to place the order and the shipping cost. Second is the carrying cost. So this includes holding cost, storage cost, risk cost, and capital cost. Third, we have the stock out cost. So the cost which result either from not having a product available for sale when required or in a manufacturing operation, this is the cost from being out of raw materials or component parts required in the manufacturing process. So stock out, no? So these are the different effects of stock out. So there's a disruption of production, including added labor and overhead cost. Second, there is extra cost of uneconomic production runs. Third, extra cost of purchasing and transportation. We also have foregone quantity discounts and loss of customer goodwill. Okay, so in determining our optimum level of inventory, we should minimize stock out cost and the least total cost. The stock out cost, carrying cost should be computed. A self-check question. So this is self-check question number 1. So this is now time for self-check question number 2. So in terms of control, we have the following inventory control systems. So first, we have a min-max system. So min-max means inventory levels are kept at predetermined minimum and maximum levels. So we also have two bin system. So inventory are maintained in two bins, whereby when the first bin is fully consumed, this would signal the need to reorder another batch of inventory. We also have the red line method. Okay, so similar to the first two systems, inventory reorder point is set once the red line is breached. Number 4, we have the order cycling system. So physical count is done at predetermined periodic intervals to determine the order point. So there's a cycle. Okay, so number 5, we have statistical inventory control system. So we use here statistical and mathematical models. So like EOQ and EBQ and others. Number 6, we have the turnover rates. So inventories that are kept in stock are based on the speed of its movement. So slow-moving inventories are phased out, while fast-moving inventory are ordered in its place. So basing only on the turnover rates. So next we have the ABC system. So goods are classified as types A, B, or C, okay, depending on its value and inventory turnover rate. And we also have just-in-time systems. Actually, this is the zero level of inventory. So this system is aiming to reduce cost of money tied up with inventory. So JIT should ensure that stock out costs are not encountered. So there should be proper supply chain analysis. Okay, so for the question, first decision question, how much inventory should an operation hold? Okay, so again, the answer to this question depends on balancing the cost associated with holding costs against the cost associated with placing an order. So the main stock holding costs are usually related to working capital. Okay, whereas the main order costs are usually associated with the transactions necessary to generate the information in placing the order. So the best known approach in determining the amount of inventory to order is the EOQ formula. So this is a mathematical formula, a mathematical model. So EOQ model, at EOQ, total ordering cost would be equal to total holding cost. So this can be solved using tabular method, graphic method, and the formula method. So let's discuss the formula method. So the formula method we have here, the formula, we have 2 times the sales, demand, or usage times the cost per order divided by the carrying cost per unit. Okay, or simply what we have learned already in previously, it is EOQ is the square root of todo K. 2 times demand times order cost divided by K, because K usually associated in financial management with the return. Okay, the return of carrying capital. Okay, so again, at EOQ, or ordering cost would be equal to carrying cost. Okay, so what is the optimum number of order placed annually? So we will have to divide the sales demand divided by the EOQ. So that will give us the number, how many times do we place an order. Okay, so we have annual ordering cost, simply the demand multiplied by the ordering cost per unit divided by the EOQ. Okay, so we also have the average inventory, EOQ divided by 2, and our annual carrying cost multiplied by the EOQ divided by 2. Okay, so again, square root of todo K. Okay, so let's try to solve this problem. So what is the economic order quantity for the following inventory policy? A firm sells 32,000 bags of premium sugar per year. the cost per order is 200 and the firm experiences a carrying cost of 0.80 per bag. Okay, so we have here the demand of 32,000, order cost of 200, and carrying cost of 0.80 per bag. Okay, so the formula is pretty straightforward. Just substitute. So EOQ is the square root of 2 times 32,000 times 20 divided by 0.08. So we get the square root of that. We will have our answer here, 4,000 bags. So our optimum order point would be 4,000 bags. Okay, so we have here our second problem. Fatima Company has determined the following for a given year. EOQ, and that is our standard order size, we have 5,000 units. Total cost to place purchase orders for the year is 40,000. Cost to place one purchase order is 100. And the cost to carry one unit for 1 year is 4 pesos. So what is Fatima's estimated annual usage in units? So here, we just need to manipulate the EOQ formula so that we can get the D, or the demand. Okay? So we have here the number of orders made, and that would be 40,000, okay, divided by 100. So we have 400 orders. Okay, because the total order cost is 40,000. So just divide the cost per order of 100. You get the number of orders that are made. So 400. So the annual requirement to get the D is simply multiply the number of orders made, 400, times 5,000, the EOQ, and that will give us the demand of 2 million. So of course, you can check the formula by 2 times 2,000 times 100 divided by 4. You get the square root of that. Of course, you will get the EOQ of 5,000. Okay, so for our second decision question, when should an order replenish its inventory? So again, the answer to this question depends partly on the uncertainty of demand, no? So orders are usually timed to leave a certain level of average safety stock when the order arrives. Okay, so the level of safety stock is influenced by the variability of both demand and the lead time of supply. So these two variables are usually combined into a lead time usage distribution. So using our reorder level point as a trigger for placing replenishment orders necessitates the continual review of inventory levels. So we have the reorder level. So this is the inventory level at which a new order should be placed to ensure that sufficient stock will be continuously available to meet future requirements. So what is the formula? So our reorder point, or ROP, is equal to the lead time usage plus safety stock. Okay, or how many units do we use during the lead time, okay, plus the safety stock, or the average daily sales or usage multiplied by maximum lead time in days. So lead time usage is the normal lead time in days multiplied by the average daily sales. Okay, so for example, you have normal lead time of 3, then average daily sales of 3,000, so that's 3 times 3,000. You have lead time usage of 9,000. So pretty straight. Safety stock is the maximum max daily usage deducted by the normal daily usage multiplied by the lead time in days. Okay, so that is our safety stock. Okay, so we have here another problem. Okay, so let's have here another problem for reorder. We have here as a raw material, okay, that a company maintains a safety stock of 5,000 pounds. Its average inventory, taking into account the safety stock, is 12,000 pounds. So what is the apparent order quantity? Okay, so we have here the average inventory units of 12,000. We less the safety units, 5,000. So we get average inventory based on EOQ, and that is 7,000. So we just multiply that by 2. Okay, so our order size, okay, is 14,000. Okay, because our average inventory based on EOQ 7,000. So to get the order size, since it is average, we multiply that by 2. Okay, so let's solve here another problem. So with stock out. Okay, so each stock out of a product sold by Aliyah company cost 1,750 per occurrence. So pag magka-stock out, there's 1,750 cost. So the company's carrying cost per unit of inventory is 5 pesos per year. And the company orders 1,500 units of the product 20 times a year at a cost of 100 per order. The probabilities of the stock out of various levels of safety stock are as follows. So we have unit of safety stock 0, probability of stock out is 50%. Units of safety stock 100, probability of stock out 30%. If we have 200 units safety stock, probability of stock out is 14%. And if we have 300, 5%. And if you have 400, 1%. So of course, you can see the probability is decreasing as we increase our units of safety stock. So the question is, what is the optimal safety stock level for the company based on the units of safety stock level? Okay, so in solving this problem, we need to get the stock out cost first. Okay, so our stock out cost is 1,750 per occurrence. Okay, so we just multiply that with the probability of its occurrence for every safety stock level. So at safety stock level, for instance, 100 units, so we get the stock out cost by multiplying the cost of stock out to 1,750 times the probability of its occurrence, 30%, multiplied by 20 orders. So we get stock out cost for 100 level of 10,500. So we just do the same procedure with each stock level. So for instance, 400 safety stock. So the cost 1,750 times the occurrence 1% times 20, we get 350. Okay, so just do the same. So after we compute the stock out cost, we get the carrying cost. Okay, so the carrying cost for 100 safety stock, so that's 100 units times 5 peso per unit. So carrying cost is 500. So the stock out cost is 10,500. The carrying cost is 500. So we have the total 11,000. So the same with 200. So our carrying cost for 200 is 200 times 5. We get 1,000. So we just add the stock out cost that we computed earlier, 4,900. We have 5,900. At 300 level, so that's 300 times 5, 1,500, plus the stock out cost previously computed 1,750. The total the total cost would be 3,250. So the same with 400. 400 times 5, 2,000, plus the stock out cost of 350. So we have total of 2,350. So the question of what is the optimal safety stock level, that is 400, because this gives us the lowest cost. So we go with the lowest cost. So we have here another problem in getting total annual cost associated with inventory policies. So we have here Aisha company uses about 200,000 yards of a particular fabric each year. The fabric costs 25 pesos per yard. So the current policy is to order the fabric 4 times a year, and the incremental ordering costs are about 200 per order. The incremental carrying costs are about 0.75 per yard, so much of which represents the opportunity cost of the funds tied up in inventory. So the question, how much total annual costs are associated with the current inventory policy? So we get the ordering cost. So we will order 4 times a year times 200 per order. So we will have ordering cost of 800. The carrying cost, so we get the carrying cost. We get the 200,000 demand divided by 4 times a year. So that means 50,000 is the average or the normal standard size of our inventory. So divide that by 2, we get the average inventory times the carrying cost of 0.75. So we get 18,750. So this is our answer. The total annual cost associated with carrying the inventory is 19,550. Okay, so as mentioned a while ago that some companies use the criteria of inventory turnover. So measures how efficiently the inventory portion of the working capital is being used in terms of the number of times inventory is replaced. So our formula is cost of sales divided by average inventory. So sometimes some companies usually use this metric. Okay, so time for self-check question number 3. Okay, so we have here another concern about the inventory control system. Okay, so in any inventory which contains more than one stocked item, of course, some items will be more important to the organization, to the business than others. So for example, some inventory might have a very high usage rate. So if they run out of stock, of course, many customers would be disappointed. So, ibig sabihin sila yung pinakagamit na inventory. So, other items might also be of particularly high value. So, of course, maintaining excessively high inventory levels would be very expensive. So, now, one way of discriminating between different stock items is to rank them by the usage value. So the usage value is the usage rate multiplied by their individual value. So items with a particularly high usage value are deemed to warrant the most careful control, whereas those with low usage values need not be controlled quite so rigorously. So generally, pag there's a relatively small proportion of the total range of items contained in inventory that will account for a large proportion of the total usage value. So we have here what we call the Pareto Law. So this is actually named after the person who described it. No, this is sometimes referred to as the 80-20 rule. So 80-20 rule is called because for Pareto Law, it stated that 80% of an operation sales are accounted for by only 20% of all the stocked item types. So, ibig sabihin, only 20% of the stock item contributed to that 80% sales. So, the relationship can be used to classify the different types of items kept in inventory by their usage value. So, we have here what we call the ABC inventory control. So this allows inventory managers to concentrate their efforts in controlling the more significant stock items. So in the ABC system, we classify inventories as Class A, Class B, or Class C. So Class A items are those 20% or so of high usage value items that account for around 80% of the total usage value. Okay, so Second is the class B items. So those of medium usage, no, usually the next 30%, no, that account for 10% of the total usage value. Okay, so and class C are those the rest, no, the low usage value items comprising around 50% and accounting for around 10% of the total usage value. So we have here a simple illustration of Pareto Law and ABC system. Okay, so this table shows the parts stored by the wholesaler. So there are 20 different items. Okay, so A703 to the 221. That vary in terms of both their usage per year and the cost per item. So you can see here the usage per part and the cost per part. Okay, so the seller, the wholesaler, ranked the stock items by their usage value. So this is the ranking of the usage value per year. So the total usage value amounts to 5,569,000. So from this, it is possible to calculate the usage value per year of each item as a percentage of the total usage value. Ito. Okay? By dividing 1,4 divided by 5,569. So we can get the running cumulative total. So the wholesaler can then plot the cumulative percentage of all stock items against the cumulative percentage of their value. So for example, the part with stock number A703 is the highest value part. Okay, it is the highest value part. The cost is expensive and it is the highest value. It accounts for 25.14% of the total inventory value. But as a part, it is only 1 over 20. It is only 1 over the 20 parts, so only 5%. Okay, so this item, together with the next, the high value item, D012, so they 2 over 20 accounts only for 10% of the number of items stock, but look at their usage, a cumulative percentage of total value. It is 47.37% of the total inventory value. Okay, so the wholesaler or the business classified the first four parts. Okay, so the A703, D012, A135, C732, they were classified as class A items, and of course they need to monitor because as a value, all in all, they are 78% of the total value of the inventory. Okay, so the company will monitor the usage and ordering of these items very closely and very frequently because a very little improvement in order quantities or safety stocks for these items could bring significant savings. So the company classified in the 6 next part, okay, part numbers C's 375 through A138 as 30%, which is 30% of the range, to be treated as Class B items. So, Class B items are slightly less effort lang devoted to their control. And the rest of the items as Class C, of course, their Class C, their stocking policy is reviewed only occasionally because it only accounts not so substantial amount of this one. Their total is not just substantial percentage of the inventory value. So as you can see here, okay, so as you can see here, there's the Pareto Law that only 20%, as I have mentioned, A703 and D012, they almost occupy almost 80% of the total value. Okay, so that is what is meant by 80-20 Pareto Law. Okay, class, so that would be all for today. So our next lesson coming up would be capital budgeting conceptual overview.